Okay, today we're talking about special right triangles. In particular, we're going to start talking about this 45, 45, 90 triangle. Objective, I will learn to prove and apply properties of 45, 45, 90 degree triangles. All right, so let's start by looking at a 45, 45, 90 triangle. And we're going to use Pythagorean theorem on this to kind of solve this thing in general terms. So remember that if the two base angles are the same, then these two sides here are the same. Okay, so I'm going to let this be x and this be x because these two sides, whatever length they happen to be, they're going to be the same. All right, and then we're going to see if there's any kind of pattern with this hypotenuse side. Okay, so for the sake of this proof, what we're kind of doing, because we're trying to want to speak in general terms, I'm going to let this side be my h. Okay, so using Pythagorean theorem, we would have x squared plus x squared is equal to h squared. Okay, and then simplifying this, we would have 2x squared is equal to h squared. Okay, and then to solve for h, we would want to take the square root of 2x squared. And then 2 is prime, so that's going to stay inside the radical. But x squared, the square root of x squared is just going to be x. Right? So if these two legs are x length, then the hypotenuse is always going to be whatever that side is times the square root of 2. Okay, so anytime that you're solving for a missing length and you happen to have a 45, 45, 90 triangle, we're going to label it this way. We're going to put x on this side, x on this side, and then this would be x square root of 2. Okay, the way I like to kind of label these, you have a 45, 45, 90. To remember this, the 45 is always opposite the x on both of these, and the 90 is always opposite x square root of 2. Okay, so here I'm going across there, and I'm on the opposite side there. Alright, so let's look at an example. Okay, so here's my 45, so that's going to be x, and if I have 45, 90, that means this up here is 45. So across of that, that's going to be x, and across the 90 would be x square root of 2. Okay, well this 5 right here tells me what my x is. So if BC has a unit length of 5, then that means the distance from A to B is also going to be 5. And then here, I'm going to replace x with 5, so AC has a distance of 5 square root of 2. Now looking at the next example, 45, 90, that means this is 45. So these are my two congruent sides. So this is going to be x and x, and this is my x square root of 2 side. Okay, so this time, instead of me giving you what the x value was, you're going to have to actually solve for the x value. So you're going to set x square root of 2 equal to 4, because that's the side that it's on. Okay, well, solving for x, we'll have to divide both sides by the square root of 2. Okay, that becomes 1, so I'm left with x is equal to 4 square root of 2. But remember, we can't have a square root in the denominator. So we have to multiply the top and bottom by the square root of 2. So that means x is going to be equal to 4 square roots of 2 over 2. And then since the 4 and the 2 are outside the radical, 4 divided by 2, I can factor that out. And I'm left with 2 square roots of 2 for x. So this is equal to 2 square roots of 2, and this is equal to 2 square roots of 2. Okay, so those are my answers. AB has a length of 2 square root of 2. Go ahead and put some units on here for both. Alright, next example. Same thing, I have a 45, 45, 90. So go ahead and go across the 45. So this is x, x. And this side is going to be equal, it's across the 90, so it's going to be equal to x square root of 2. Right, so I need to figure out what my x's are. So x square root of 2 is equal to 3 square roots of 15. And like before, you're going to divide by the square root of 2 on both sides. Okay, that becomes a 1. So x is equal to 3 square root of 15 over the square root of 2. Okay, can't have a square root in the denominator. Okay, so this is square root of 2 times square root of 2 is just going to be 2. And then this is going to be 3 square roots of 30. 15 and 2, that's not going to simplify. So this is my answer in simplest radical form. So 3 square root of 30 over 2 for that one. And 3 square root of 30 over 2 for that side. In our last example of these special right triangles, these 45, 45, 90s. Okay, so 45, 90, and this is 45. So here's my x. Here's the other x. And this one is x square root of 2. Okay, well, if AB has a length of 2 square root of 3 units, then BC is going to have a length of 2 square roots of 3 units. So that's half done. Now we need to substitute 2 square roots of 3 for x. So this AC side is going to equal 2 square roots of 3 times the square root of 2, because this is going to be my x. Okay, so then multiplying, that gives me 2 square roots of 6. 6 doesn't factor, so this is the actual length. So this side is going to be 2 square root of 6 units.